Hi everyone, welcome to lesson 4.1, video 3, calculating compound interest. So today we're going to be talking about how to calculate compound interest and a little bit about what that is. So to start off, we have a quote from Albert Einstein, which says, "Compound interest is the eighth wonder of the world. He who understands it earns it, and he who doesn't pays it." Compound interest is just saying that interest that you are earning in your investment. So if you put your money into a bank account and say you put $1,000 in, it earns $100 of interest in a year. Now you have $1,100, and that $1,100 is going to be earning interest as well. So it keeps getting compounded year after year. And so it's going to multiply faster and faster because that interest is going to be earning interest. And the more frequently your money is compounded, so the more frequently that interest is compounded, the faster it's going to grow. So here is the compound interest formula. You can see this on page 12 of your notes. And we're just going to fill in some of these blanks really quickly here. So we have A equals P, parentheses 1 plus R divided by N, and parentheses to the N times T power, where A is our total after interest. So that's going to be your principal plus compounded interest. P is the principal, which is just your starting amount. That's what you are depositing into the account. R is your interest rate, and we're going to write that as a decimal. N is how frequently the interest is compounded in a year. So you might have interest that's compounded daily, weekly, bi-weekly, monthly, quarterly, something like that. And then T is the actual number of years. So take a second and write that down in your notes. And now we're going to look at an example. So we have Justin's dad suggests putting his $500 into a CD that earns more interest more frequently. Their credit union currently offers 2.5% APY on a 12-month CD, and interest is compounded daily. So we're going to take a second and use that formula to calculate how much Justin will have after 1 year if he goes with the CD option instead of just a simple interest. So we're identifying our principal, our interest rate, the frequency with which his interest is compounded, and then also the number of years. So our principal is $500. That's what we're starting out with. That's what Justin's going to put into his account. The interest rate looks like it's 2.5%. And we're going to write that as a decimal, so 0.025. It is compounded daily. So there are 365 days in a year. So N is going to be equal to 365. And then T is the number of years. In this case, we're just looking at 1 year. So we're going to take these numbers and substitute them into our formula. I have also given you a calculator right here. Once you've written out the formula, you can actually just plug that the expression into this calculator and it'll give you the answer, but I'm also going to show you how to work it out step by step. So the first thing we're going to do is put A equals 500 times 1 plus 0.025 divided by 365 to the 365 times 1 power. And all we're doing is basically taking this formula. We know that P is equal to 500, so instead of P, we're going to write 500. We know R is 0.025, so instead of R, we're writing 0.025 divided by N. We know N is 365, and then to the N times T power, so 365 times 1. And then all we're doing is step-by-step order of operations. So the first thing we're going to do is divide. So we're going to do 0.025 divided by 365. You're going to get a really long decimal. So we're going to end up getting A equals 500 times 1 plus 0. This is just really long decimal. 365 times 1 is 365. And then we're going to take that long decimal times to the 365th power. We're going to get A equals 500 times 1.0 long. Multiply that by 500, you get 512.66. That's really it for compound interest.